Greetings of the day. Today we'll have a very brief discussion on a very interesting topic, reasons for seasons. If I was to sum up the whole topic of seasonality in just one point, I would say it is the consequence of the changing relationship of Earth and Sun in 1 year's time. As Earth revolves around the Sun in 1 year's time, for some reasons which I'm going to state very soon, the relationship between the Earth and the Sun keeps changing. To me, it's something like human relationships. As relationships change in our human lives, there are certain consequences of it, and in the case of Earth and Sun, the consequence is seasonality. One major manifestation of this seasonality is the changing length of a day. As darkness starts prevailing earlier in the evening, it's a signal for all of us in the Northern Hemisphere that we are approaching winter. It means the days are getting shorter and nights are getting longer, and summer is a time when the days are longer and the nights are shorter. Now, the question arises here, what leads to this changing relationship of Earth and Sun? Before I mention those reasons, those factors, let me first talk about the very change of relationship. In December, when we have winter in North Hemisphere and Australians have summer, the Earth is so oriented to the Sun that Northern Hemisphere is leaning away from the Sun and Southern Hemisphere is leaning towards the Sun. And on this particular day, 21st December approximately, the Sun is so placed with this Earth that Sun appears to be overhead at Tropic of Capricorn, that is 23.5 degrees south. As Earth goes around the Sun in the next 3 months, every day the relationship keeps changing, but daily changes are so minor that we would not be able to comprehend them easily. So our scientists comprehend or mention, describe and explain these changes on certain important days of the year, what I call as 4 anniversary dates of Mother Nature. One is December solstice. By solstice we mean that Sun is farthest in the given hemisphere. For example, that Sun is farthest in Southern Hemisphere on approximately December 21st or 22nd, that is Sun is overhead at Tropic of Capricorn. But as Earth goes for the next 3 months journey, after 3 months, the orientation is so changed that Sun appears to be overhead at the equator. And this particular anniversary date is called as March Equinox, or we in Northern Hemisphere will call it as Spring Equinox, and the people in Southern Hemisphere, Australians, would call it as Autumnal Equinox. And Equinox is that day of the year when you have all the places having equal length of the day and night. The Sun is right over the equator now. Now see the interesting thing, that it is the Earth which is moving around the Sun. Sun is stationary, but because of the changing relationship of Earth and Sun, it appears to us as if Sun is also moving. It means you are going to see within a few minutes of time that in 1 year's journey of the Earth around the Sun, there is an apparent movement of the Sun between the 2 tropics. On 21st December approximately, Sun was overhead at Tropic of Capricorn, but after 3 months, on 20th March approximately, Sun appears to be overhead at the equator. So Sun appears to move from Tropic of Capricorn to equator, and as Earth goes further for the next 1/4 of its orbit, after 3 months, on June 21st, which is called June solstice, the Sun appears to be overhead at Tropic of Cancer, that is 20.5 degrees north, because the Northern Hemisphere is leaning towards the Sun and Southern Hemisphere is leaning away. We have summer in Northern Hemisphere, and people in Southern Hemisphere like Australians would have winter. And as the Earth goes for the next 3 months journey, the relationship again keeps changing, and after 3 months, on 22nd or 23rd September approximately, the Sun is overhead at the equator, and we'll call it as September Equinox. All places of the Earth would again have equal length of the day and night. And for we in North Hemisphere, it is Autumnal Equinox, and for the Australians in Southern Hemisphere, it would be the Spring Equinox. So it means there are 2 solstices and 2 equinoxes, which are the 4 anniversary dates of Mother Nature. And these are the dates on which we generally describe the changing relationship of Earth and Sun. By solstice, we would mean the Sun reaching the farthest in a given hemisphere, or we'll say Sun appearing to stand still. Sun is standing still at Tropic of Cancer and Tropic of Capricorn on these particular days. So it means the story is that as Earth goes around the Sun, relationship between the Earth and the Sun keeps changing, and as a result of this changing relationship, Sun appears to move between the two tropics. And the farthest reach of the Sun in Northern Hemisphere is 23.5 degrees north, and in the Southern Hemisphere it is 23.5 degrees south. It means these two tropics are the farthest limits of the overhead position of the Sun, or we can call it as that these are the these are the farthest limits of the vertical rays of the Sun. It means beyond the tropics, no place on the Earth would have the vertical rays, the overhead position. And we have a concept called Sun's declination. By Sun's declination, we mean the parallel where on a particular day the Sun is overhead. For example, I say on 20th March and on 22nd or 23rd September, Sun is overhead at equator. So the Sun's declination on these 2 days is 0 degree parallel, that is equator. And on the solstices, December and June, we have the Sun being overhead at Tropic of Capricorn and Tropic of Cancer. Now, if you have understood this point, that seasonality is basically the outcome of changing relationship of Earth and Sun, then the next question of interest to us is that what are those factors which are involved in this changing relationship of Earth and Sun? Now, there are 5 factors. One is that Earth is revolving around the Sun. This is one factor. The second is that as Earth goes around the Sun, it is also rotating on its axis. By axis, we mean the imagined line joining North Pole with South Pole passing through the center of the Earth. And the third is that in this journey, we have also the role of the tilt of the Earth's axis. Now, this Earth's axis, if you take my pen as the Earth's axis, the line joining North Pole with South Pole through the center of the Earth, this axis is not so placed in the nature, it is tilted. And I'll make you understand today the tilt of this Earth's axis in reference to a plane called ecliptic plane. Since this tilt of the Earth's axis is 23.5 degrees, and that is the reason that the farthest position of the Sun in each hemisphere is only up to Tropic of Cancer and Tropic of Capricorn, that is 23.5 degrees north and south. So the third reason is the tilt of the Earth's axis. The fourth reason is that as Earth goes around the Sun in 1 year's time, the Earth's axis remains identically oriented. And this particular identical orientation, the unchanging orientation of the Earth's axis in this entire journey of 1 year is technically called as axial parallelism. Now you notice in this sketch, this black line represents the Earth's axis. Now, as Earth is going for this journey of the 1 year time around the Sun, this axis remains identically oriented. And why do we call it as axial parallelism? Because the axis remains parallel to all its previous positions. So, as Earth goes from December to March to June and to September, the axis remains always parallel to all its previous positions. And another important point is that in this tilted axis position, the axis is oriented towards a star, Polaris. The North Pole is towards the star called Polaris, and that star is also appropriately called for this reason as the North Star. So, the fourth reason for seasonality is that as Earth goes around the Sun, the axis remains identically oriented, means it remains unchanged throughout this journey, and it is called as axial parallelism. Now, what is the last factor which is operating this seasonality? That is the spherical shape of our Earth. We find that the intensity of insolation we have in a particular season, it's not same from equator to the poles. And in this variation of insolation from equator to the poles, we have the role of the curved surface of the Earth. Imagine if the Earth's surface would have been flat like my left hand like this. So this flat surface would have offered to all the incoming parallel rays of the sun same angle of incidence everywhere. But since our earth surface is curved, being spherical in shape, so this curved surface becomes the reason for providing varying angle to the incoming parallel rays of the sun at different latitudinal locations. So I repeat, there are 5 factors which are operating together for this causation of seasonality. One is revolution of the earth around the sun. The second is rotation of the earth on its axis. The third is the tilt of the earth's axis. And the fourth is axial parallelism. And the fifth is the very spherical shape of the earth. Now, we need to have 1 or 2 clarifications here for better understanding this concept of seasonality. The first clarification I would like to share with my students is that do remember that as earth goes around the sun, since the elliptical orbit would give you the distance between the earth and the sun getting changed, means as earth goes around the sun in elliptical orbit, so there would be changing distance between the earth and the sun, and this does amount to variation in the amount of insolation on the earth's surface. But the point you need to understand is that this varying distance of earth and sun, because of the elliptical orbit of the earth around the sun, which logically appears to be a reason for seasonality because it leads to variation in the amount of insolation, scientists have discovered that this elliptical orbit, this changing distance of the earth and the sun, doesn't manifest itself as a reason for seasonality. Though when earth is closest to the sun in its orbit, what you understand or what you have been calling as perihelion position, peri in Greek refers to something about or around, means closer position. And in this particular perihelion position, earth is approximately 147 million kilometers from the sun. And in this closest position of earth in its orbit around the sun, earth does get about 7 or 8% extra energy as compared to when the earth is the farthest in its orbit from the sun, what is called in school science as aphelion. Ap in Greek means away, that earth is away from the sun. Helion is sun, so perihelion is closest position, closer position. Aphelion is the position away, means the farthest position. And when earth is farthest from the sun, the distance between the two bodies is approximately 152 million kilometers. So in the closest position of the earth around the sun, earth does get around 7 or 8% more energy, but scientists of the world have discovered that this variation of 8% or so is not able to manifest itself as a reason for seasonality. Now, what could be the evidence or the proof to understand this? The evidence is that the perihelion position, means closest position of the earth to the sun, is approximately occurring on 3rd of January. So think of that 3rd of January, when we in Northern Hemisphere have winter at its peak, we are closest to the sun. So that clearly illustrates that distance of earth and sun is not a factor for seasonality. And similarly, you'll find that our aphelion position occurs approximately on the 4th of July. We are farthest away from the sun on 4th of July, means the peak of summer in North Hemisphere. So it means these two dates clearly illustrate that the distance, the elliptical orbit, is not a reason for seasonality. I can give you another interesting point for understanding the same. That on 3rd of January, when we are closest to the sun, we have winter in Northern Hemisphere and the Australians have summer in Southern Hemisphere. Since summer of Southern Hemisphere is in the closest position of the earth to the sun, on the face of it, one may say that this summer of Southern Hemisphere should be more intense than the summer we have in the Northern Hemisphere, because our summer is when we are farthest away from the sun, that is on 4th of July, but we find that because of more water in the southern hemisphere, we do not have the summer of southern hemisphere in the month of January that severe as it appears to be or it should be if the distance was important. So it means one important clarification is that the varying distance of the earth and the sun and the journey of the earth around the sun, which logically appears to be a reason, in reality it is not found to be a reason for seasonality. Now, one other clarification I need to give for students is that many students misunderstand that when it is equinox position, means when earth and sun are so placed that none of the two hemispheres is leaning away from the sun. Some students believe that in this particular relationship as if the tilt of the earth's axis is not there. Remember, seasonality is not about the change of the tilt of the earth's axis. Seasonality, as I said in the very beginning of the lecture, was that as earth goes around the sun, the relationship with the earth and the sun keeps changing. Remember, the tilt of the earth's axis remains constant, that is 23.5 degrees throughout in this journey of 1 year around the sun. That the tilt will remain same for our lives on this planet. And remember, tilt has a slight change over some thousands of years of cycle, and that particular change would relate to not the topic of seasonality presently, it would relate to the topic of climate change, which is the consequence over a longer time period framework in terms of say thousands or some millions of years as such. So I repeat, seasonality is only about changing relationship of earth and sun as per the 5 factors which I have just mentioned. They are acting together. And one more important point you have to always remember is that seasonality as seen on the earth's surface is the combined effect of 5 reasons. I repeat, the revolution, the rotation, the tilt of the earth's axis, the axial parallelism and the spherical surface of the earth. By combined effect I mean that the relationships are so complex, the phenomenon is so complex that we can't quantify the role of each factor separately. And that is why you will find that every good book of geography would give you the combined result as seasonality. No good author would ever try to rank these 5 reasons in any ascending or descending order of the importance of these factors as such. So it's always to be seen as a combined effect because of the complexity of this whole operation which is there of these physical factors, the 5 which I mentioned. Now, I said changing relationship, it means orientation of the earth's axis or the orientation of the earth is vis-a-vis the sun is changing. That is that the northern hemisphere is leaning away sometime and sometime it is leaning towards and sometime none of the two hemispheres is leaning away or towards the sun. Now, if this is all understood, now let's bring that how there is a changing length of a day on the earth's surface as the seasons would change or along the different times of the year as such. Now see, as earth goes around the sun for 1 year's time, at every moment of this journey, the sunlight divides the earth into 2 exact halves. One is called the sunlit hemisphere or the light half, and that is the day, and the other half is called as the dark half. If you take my left hand as the earth, and let's say the portion towards you is the light half and the portion towards the board is the dark half, then the edge of this light half, the sunlit hemisphere, is what we call as circle of illumination. And this circle of illumination is a great circle. By great circle we mean that a circle which cuts a sphere exactly into 2 halves. So it means nature has given us a beautiful example of great circle for which we study in mathematics for a spherical shape. And this great circle example is circle of illumination. And what you need to appreciate here is that as earth goes around the sun in 1 year's time, the circle of illumination is like a knife which is cutting my earth always into 2 halves, but it does so differently at different times of the year. Mind this point, that it's something like you can cut an apple with the help of a knife into 2 halves in n number of ways. The same way we are having the things in nature, that my earth is being cut always into 2 halves, but the knife called circle of illumination. and this circle of illumination is cutting my earth differently at different times of the year. Now the question is, why this circle of illumination is cutting my earth differently at different times of the year? The answer is simple, that as earth goes around the sun in 1 year's time, the relationship with the earth and the sun keeps changing, means the earth is orienting itself to the sun's light in different ways at different times of the year. So the light has to cut the earth in two halves differently at different times of the year, and that becomes the reason for the change in the length of the day. Now, if changing length of a day is the manifestation of seasonality, then what else could be a manifestation of seasonality? Then I'll say, you can notice here that as earth goes around the sun in 1 year's time, the sun is stationary, but because of the changing relationship, sun appears to move. And sun's apparent movement is between the two tropics. And if I show you by dates, the 4 anniversary dates, on December solstice, what we Indians will call as the winter solstice, and the Australians would call it as winter solstice, the sun is overhead at Tropic of Capricorn. But after 3 months, on 20th March approximately, sun is overhead at equator. Then sun in June, 21st June approximately, is overhead at Tropic of Cancer, and that is June solstice, or we Indians will call it as summer solstice, and the Australians will call it as winter solstice. And after 3 months we have September equinox, and this is autumnal equinox for the people in North Hemisphere, and for Australians it would be spring equinox as such. Okay, so it means, what is the other manifestation of seasonality? Other manifestation is that overhead position the sun is changing. By overhead position, I mean sun's declination is changing. So sun's declination on 21st December was 23.5 degrees south. After 3 months it's equator, and after another 3 months it is Tropic of Cancer, 20.5 degrees north, and after 3 more months it is equator again. It means in 1 year's time there is an apparent movement of the sun also as a manifestation of seasonality. What would be the third manifestation of seasonality for we people on the earth? And that is the position of the sun in the sky. Now, how do we check the position of the sun in the sky? How do we measure this position? Then we have a concept called sun's altitude. Now, sun's altitude is the angle between the sun and the horizon. By horizon we mean the apparent line where earth and sky seem to meet. When you are in an open space, you find a magic in distance. That is, when you look far in distance, you have a feel as if the earth's surface and the sky meet with each other. If I take this hand as that particular apparent line where earth and sky meet or seem to meet, then I call it as horizon. And if this pen is the sun, then the angle between this horizon and the sun would be the sun's altitude. At the time of sunrise or sunset, this angle is 0, but as the sunrise takes place and the day progresses, this angle increases, and at 12 noon local time, the sun reaches highest, and that particular moment is called as noon sun angle. And the third manifestation of seasonality would be that as earth goes around the sun, for different places of the world, the noon sun angle would keep changing. It means, I sum up once again, seasonality gets manifested in 3 different ways for us. One is changing length of a day. The second is the changing sun's declination, means the overhead position of the sun is changing, and it is changing between the 2 tropics. It means the total migration of the sun's declination in 1 year's time is 47 degrees. That is 20.5 degrees north and 20.5 degrees south. And the third is that sun's altitude is changing. For example, I can say in a simple way that summer is a time when there is high sun period, and means the sun is high, it is high sun period, and when it is winter, the sun is low in the sky. So summer is high sun period for us, and the winter is low sun period. It means during winter, the sun is on the other side of the equator, and the rays of the sun will come more inclined, and they would be diffuse hitting on the earth's surface. Now, let me show you quickly that what is the tilt of the earth's axis. Now, the tilt of the axis is to be seen with a concept or a frame, that is an imaginary plane, what is called as plane of ecliptic. And this plane of ecliptic is the reference plane with which we can understand the tilt of the earth's axis. The earth's axis is tilted means the line joining North Pole with South Pole is tilted at an angle of 23.5 degrees with respect to the perpendicular drawn to the plane of ecliptic. And this angle between the plane of ecliptic and the axis is 66.5 degrees. But the question arises, what is ecliptic plane? Let me make it easy for you. You know, Earth goes around the Sun in an orbit. If I visualize that orbit of the Earth around the Sun as a plane, then that plane is called as ecliptic plane. It means if Earth is going around the Sun here, then this hand in which lies the orbit of the Earth around the Sun is my ecliptic plane. Or I can make it easy by saying that if this is a vessel in which we have this much of water, and if I take this ball which is half submerged as Sun, and if I take a smaller ball half submerged as Earth, then the surface of the water would act as ecliptic plane. So ecliptic plane is a plane with which we can understand the Earth's axis tilt. Now I make it easy by showing you like this. If you take this pen to the representation of the ecliptic plane, then to understand tilt of the Earth's axis, first I'll draw a perpendicular line on it, and then I'll say that this red pen is the Earth's axis and this axis is something like this here. So this is ecliptic plane, this is the perpendicular drawn, and the red pen indicates or represents the Earth's axis. This is North Pole, and somewhere here it is South Pole. This angle which you see between the red pen and the blue pen, the vertical pen here, this is 23.5 degrees. And this angle with the plane, ecliptic plane, the plane in which lies the orbit of the Earth is 66.5 degrees. Now where is equator in this picture? My hand would represent the equator. Equator is here. So generally we represent in books the Earth like this, but that's a simplified presentation. When we discuss the topic of seasonality, we have to reveal the truth that Earth's axis is not the way red pen is put now. The Earth's axis is tilted, means Earth is tilted like this. And what could be the reason for this tilt? Scientists can only make a guess, and it is believed in science that in the primordial times, billions of years back, some billions of years back, there was a collision of the Earth with some other body, and because of that primordial collision, we had this tilt of the Earth's axis. Now the important point is that as Earth goes around the Sun in 1 year's time, this North Pole is pointing to a star, not very exactly, it's little off the mark, but this pointing is towards a star called Polaris, or we call that star as North Star. So this is how we understand the tilt of the Earth's axis. Now, so remember, tilt doesn't change in this 1 year's journey. It is the relationship of Earth and the Sun which is changing. Now, let me show you in this small table the result. The 5 physical factors we have discussed. One is the revolution of the Earth around the Sun. Second, the rotation of the Earth on its axis. The third, the tilt of the Earth's axis. Fourth, the axial parallelism. By axial parallelism, I repeat, as Earth goes around the Sun, the orientation of the Earth's axis doesn't change. It means that North Pole keeps looking towards the same star. Polaris throughout this journey means, in a way I can say, high level of commitment. And the fifth reason was the curved surface of the Earth. And what is the final result? The combined effect of these 5 factors gives us the seasonality, and that seasonality is generally, as a convention, is expressed in a table like this, that on December 21st, 22nd, in North Hemisphere, we name this particular date as winter solstice, that Sun has reached the farthest in the Southern Hemisphere, that is Tropic of Capricorn. So that is Sun's declination. And after 3 months, on 20th March approximately, you have spring equinox, or which is also referred to as vernal equinox, and Sun appears to be over the equator. And after 3 months in June, which is summer solstice for we Indians, and for Australians it would be winter solstice, and the Sun is overhead at Tropic of Cancer. And after 3 months again, you have the autumnal equinox, that is Sun is again overhead at the equator. Now, let me just tell you about one important point once again, that circle of illumination is a great circle. It cuts the Earth exactly into 2 halves. And the point you need to understand is that being a great circle, it has to cut the earth always into two halves, but it is doing so differently at different times because of the changing relationship. So let me show you one last point here. If I take this particular case of June 21st, let us see how the earth is being cut by the sunlight on 21st June when the sun is overhead at Tropic of Cancer. So, circle of illumination is acting like a knife and it cuts the earth this way. And you find as a result of it, there is half length of the equator under sunlight and half length under darkness. And I hope you all know that equator is the only parallel of the earth which will always have throughout the year 12 hours of day and 12 hours of night. Why? Because remember, whenever you cut the apple into two halves, knife has to pass through the center of the apple. It means, technically speaking, equator is the only parallel of the earth which always get cut evenly by the sunlight. So throughout the year you have half length under sunlight and half length under darkness. But all other parallels will get cut unevenly throughout the year, except 2 days of the year, that is equinoxes. And if you do not take the equinox, if you take the June 21st, that is the summer solstice, you find the northern hemisphere in June is the summer hemisphere. And do you notice, as I go higher, you find the summer length of the day is increasing. It means proportion of night is decreasing here and the day length is increasing. And perhaps you have heard of something called as daylight saving time, that the countries which are in middle and high latitudes, they go for forwarding their watches for the summer season when the days are longer, and that practice of forwarding the watch for the summer season is giving them energy conservation. And this daylight saving time is appropriate for the higher latitudes only, because the seasonal variation in the length of a day keeps increasing towards the poles. It means in India we have summer length of the day more than winter length of the day, but this difference is not much. But when you go to Europe or higher latitudes, the summer length of the day is much more than the winter length of the day. And that is the reason that they want to use the sun's energy, which is given to them for more number of hours in summer. They want to use it more efficiently. And this they achieve by forwarding their watches before the summer begins in the season called spring. And having used the forwarded watch by usually 1 hour, they have the energy conservation, they use the sun's energy more efficiently, and when winter is about to come back, when the days are again getting shorter, before that happens, that is in the autumn season, the fall season. Autumn is also called fall in these countries in higher latitudes. So in the fall, they bring their watch back to the original standard time. So the DST, daylight saving time, is referred to as spring forward. In spring, they forward their watches, and in fall, they come back, means in the autumn season, they come back to the original system of watch. So, in brief, this is the presentation for the formation of seasons on the earth. And in details, when we cover this topic, we need to cover the details about all the 5 factors, that how they are operating, and they will go for the details of the changing relationship of earth and sun. I believe this was useful for you. Thank you very much. Thank you.